Hi, I am T. Kavita, Assistant Professor, Department of Mathematics. Today we are going to see the problem of chi-square test, the test hypothesis for small sample test. What is chi-square test? That is, the chi-square test is a non-parametrical statistical test used to determine whether there is a significant difference between observed frequencies and expected frequencies, or is one or more categories. That is, the chi-square test is a statistical test used to determine whether there is a significant difference between observed frequencies and expected frequencies in categorical data. It is based on the chi-square distribution. That is, in the chi-square test is widely used in statistics for analyzing categorical data and helps in decision making by testing hypotheses about relationships and a distribution. What is a chi-square test? That means the chi-square test measures how well the observed data fit with the expected data under a given hypothesis. That is, again, the chi-square test measures how well the observed data fit with the expected data under a given hypothesis. The test statistics is given by the formula for this chi-square is equal to summation of O minus E the whole square divided by E. That is, O means observed frequencies and E means expected frequencies. Then uses of chi-square test is the test of goodness of fit. The first main use is test of goodness of fit to determine whether the observed data follow a particular theoretical distribution. That means it is binomial or normal. The second one is test of independence of attributes. Third one, test of homogeneity. Fourth one, analysis of contingency table. Fifth one is testing hypothesis in social sciences and business research. Then to check whether two categorical variables are independent or associated. That is, relationship between education level and employment status. That is the test of independence of attributes. This is the uses. The next problem is give the formula for goodness of fit in a chi-square. That is the observed frequency minus expected frequency whole square divided by AI. We have to the step-by-step calculation is first the chi-square test. The goodness of fit test is used to check whether the observed frequencies agree with the expected frequencies from a theoretical distribution. Formula we already given that the degrees of freedom, that is n minus 1. If the sample space number of categories is n, therefore the degrees of freedom is n minus 1. Thus the chi-square goodness of fit statistic compares the observed and expected frequencies to determine whether the difference is statistically significant. Give the formula for independence of attributes in chi-square test. The chi-square test for independence of attributes, we test whether two attributes are independent in a contingency table. Then the expected frequency formula is a row total and column total divided by n. That is, row total into column total divided by n. Next we have to find the chi-square test statistics formula. This is the properties of chi-square distribution. The chi-square distribution has the following important properties. That is, non-negative values, continuous distribution, right skew distribution, depends on degrees of freedom, then mean and variance. They become symmetric for large as the degrees of freedom, additive property. These properties make the chi-square distribution widely used in goodness of fit test of independence and test of homogeneity. The next problem is A retail chain manager claims that customer footfall in their store is evenly distributed across the 6 days. It is open Monday to Saturday. That is approximately 16.67% of weekly customers visit on each day. Over a period of 8 weeks, a total of 720 customers were recorded with the following observed distributions. The data are given: day of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and total is given. Observed frequencies are given. Expected week frequencies we have to calculate. The question is, using a chi-square goodness of fit test at alpha, the level of significance level is 0.05. Test whether the customer footfall is uniformly distributed across the 6 days. The critical value chi-square table value is given here, 11.070. Okay, now we have to find the chi-square goodness of fit. This is the calculation. First we have to find the null hypothesis. Null hypothesis is the given hypothesis: customer footfall is uniformly distributed across the 6 days. We take that null hypothesis as uniformly distributed across the 6 days. The second step is alternative hypothesis, that is H1. It is customer footfall is not uniformly distributed. We have to take customer footfall is not uniformly distributed. Now we have to find the expected frequency value. Here total number of customers values are given 720. Therefore n is equal to 720. Now total number of customers n is equal to 720. The number of days is 6. Therefore expected frequency is, we have to 720 divided by 6, 120. Thus the expected frequency for each day is 120. In each day they are given the observed frequencies different values. Now we calculate the expected frequency for 6 days as common as 120. Next we have to find the test statistic for chi-square. Test statistic form of chi-square is equal to summation of observed frequency minus expected frequency whole square divided by E. The days are given. Observed frequency value is given 98, 102, 108, 110, 142 and 160. Expected week frequency we find that 120, 120, like that. Now we have to find the first step, observed frequency minus expected frequency. Therefore 98 minus 120, that is minus 22. Like that the next value is 102 minus 120, that is minus 18. 108 minus 120 minus 12. 110 minus 120 is equal to minus 10. 142 minus 120 is equal to 22. 160 minus 120 is equal to 40. Now we square these value, observed frequency minus expected frequency, the whole square. Therefore the minus 22 square is equal to 484, minus 18 square is equal to 324, minus 12 square is equal to 144, minus 10 square is equal to 100, 22 square is equal to 484 and 40 square is equal to 1600. Now the formula is observed frequency minus expected frequency whole square divided by E, the expected frequency. Now we divide the values, 484 divided by 120, that is 4.03 as like that. Now we have to add this value. Chi-square is equal to 4.03, 2.70, 1.0, 0.83, 4.03, 13.33. That is the total value is 26.12. This is our calculated chi-square value. Now the degrees of freedom value is k minus 1. Number of columns number of values minus 1. Therefore rows or columns, that is minus 1. 6 minus 1 is equal to 5. Critical value of chi-square value is given, that is 11.07. Now our calculated value is greater than table value. Therefore we reject our null hypothesis. Calculated value is greater than table value. Now we reject hypothesis. What we reject? 5% level of degree. The customer footfall is not is uniformly distributed, it rejected. Now we conclude that the solution is customer football is not uniformly distributed across the 6 days. This is our solution. Thank you.